Find the magnitude of each of the following vectors: 2, 3, negative 4, 2, and 12, negative 5. These are vectors in R2, the xy plane. And to find the magnitude of a vector, if you have a vector v, then the magnitude of v is indicated by putting the vector in absolute value bars. So this does not mean absolute value. If you put a vector in there, it means magnitude of the vector. And to find the formula for the magnitude of a vector, suppose we have a vector v here in standard position, so starting at the origin, initial point at the origin, and terminal point at some AB, then we can make this right triangle here. And this side of the right triangle has length A, this side has length B, and we would like to know the magnitude of the vector v, which is the length of the hypotenuse. And of course, c squared is equal to a squared plus b squared by the Pythagorean theorem. And so c will be the positive square root of a squared plus b squared. So if the vector v is equal to the vector AB, then the magnitude of v will be the square root of a squared plus b squared. So this is the formula for the magnitude of a vector in R2. So we'll just use this formula 3 times. The magnitude of the vector 2, 3 will be the square root of 2 squared plus 3 squared, and that's the square root of 13, 9 plus 4. The magnitude of the vector negative 4, 2 is the square root of negative 4 squared plus 2 squared. 16 and 4, square root of 20, and we could take out a 4, so it's 2 times the square root of 5. 20 is 4 times 5, and so the square root of 20 is the square root of 4 times the square root of 5. And finally, the magnitude of 12, negative 5 is the square root of 12 squared plus negative 5 squared, and that's the square root of 144 plus 25, and that's 169, and the square root of 169 is exactly 13. So the magnitude of a vector in R2 is found by taking the square root of the sum of the squares of the components.